Hi everyone, we are going to carry on with our new lesson, Electrostatics, lesson 5. As you know, we start Electrostatics, grade 11 physics, final exam revision questions and answers. So what you are going to do first, please get from link or questions, try first, and then we can answer together. And then you can see, you can correct your answers. All right, let's continue with our first question for today. As you know, every day we have 3 questions. Every lesson we are having 3 questions. Question 1. We have 3 charges, negative 1 microcoulombs, and then positive 2 microcoulombs, and positive 2 microcoulombs, distance between each 10 centimeters. Okay, so for now, there's no question. Let's continue. Question 1.1. What's the magnitude of force? That's the negative 1 microcoulomb charge and one of the positive 2 microcoulomb charges. So between these two, asking charge between these two. Let's see our answer. As you know, we are using our formula. Force equals K times Q1 times Q2 over R squared. So K is 9 times 10 to the power of 9. And Q1 is 1 times 10 to the power of negative 6. We are using micro, we are converting from microcoulomb to coulomb, 10 to the power of negative 6, you know that. And what else we have? 2 times 10 to the power of negative 6. We are converting all. And what's the next step? Distance from centimeter to meter, it says 10 centimeters. 10 centimeters is 0.1 square. So when you calculated this force between positive 2 microcoulomb and negative 1 microcoulomb is 1.8 newtons. Direction we don't need because they are asking the magnitude only, so we don't need direction. This is our question 1.1. Let's continue with next question. Let's see what else they are asking. So now, draw the force diagram. All right, we know force diagram on the system, on the diagram, just on our charges we are drawing forces. So this is force diagram. Direction and magnitude of forces, okay, act on negative 1 microcoulomb and plus 2 microcoulombs on the left side triangle. But you are removing second 2 microcoulombs. This one is going now. If this negative 2 is going, what's going to happen? They are asking you, this one is gone. They are asking you to draw force diagram between these two. As you see, it is positive, that one is negative. If it is positive and other one is negative, we know they attract each other. Let's see our answer now because everything is ready here. So they attract each other. So positive 2 microcoulomb and negative 1 microcoulomb, they attract each other, 1.8 newtons. We calculate already in question 1.1. You remove this one and only you are calculating force between 1 microcoulomb and 2 microcoulombs. Done. And then next question 1.3. 2 spheres, okay, positive 2 microcoulomb charges still coming back, okay, now coming back this one. And then, they said what? 2 charges carrying positive 2 microcoulomb charge held in position, all right. A negative 1 microcoulomb charge is replaced by positive microcoulomb, all right. So you are making positive this one. So plus 2 microcoulombs you have, and add just changing negative 1 with positive 1. Okay, so let's see what they're asking now. Draw 3-body diagram to show direction and, okay, now positive and positive. So we should change our diagram. So now you have positive 1. If you have positive 1, what we know, they repel each other. So this one repel this way, another way. We'll see now. Next slide, you are going to see they repel, both of them repel because all positive. If all repel, we are going to see what kind of shape is coming now. Something like this on positive 1 microcoulomb. So it is just repel, another one repel. Draw 3-body diagram Okay. Resultant force also we are drawing here. Free body diagram on this charge. We are drawing just using dots. We are not using charge anymore because we are not saying force diagram, free body diagram using dots. All right. So this is our free body diagram. Calculation for now we don't need. They are asking only draw free body diagram. Let's continue. I hope everything is fine because there is a positive one now. You have positive, they repel each other. Because of that, this direction. Other one, other direction. Let's continue with next question. So two spheres carrying, okay, you change already 1.3. 1.32 now. Magnitude of force between plus 1 microcoulomb will be less than 1 Newton. Greater than 2 Newtons or greater than 5 Newtons. What is your answer? So when you check, it's gonna be more than 2 Newtons. You can say how and why. You just check this one. As you see, 1.8 Newtons. Your force, of course, just 1.8 and 1.8 just coming together, they don't opposite. So your force will be more than 1.8, more than 2, and then less than 5. You can calculate with angle also. You can just calculate it. This is just estimated between 2 and 5. So you can say this answer now more than 2. More than 2 Newtons. You can show with calculation with long way, but you see on the diagram, people. On the diagram, you are going to see why more than 2 Newtons. Next question. The answer is here, more than 2 Newtons. Question 1 done. As you see, they ask too many things. Okay. Now, we have two charges, Q1 and Q2. Distance, 3 meters. Okay, distance between charges, 3 meters. And then we have a point 2 meters away from 20 microcoulombs. Okay, this is our charges and points. Let's see what they're asking. Define the electric fields at a point in space. Yes, in this topic, electrostatics, what kind of definition, what definitions they can ask you? They can ask you Coulomb's law. What is Coulomb's law? Most probably they are going to ask you, what is Coulomb's law? It's a very important one. Other video we have done already. And then what's electric fields? Define electric field, they can ask. And then what else they can ask you? Maybe what's electrostatics, they can ask you. And electrostatic force, no, I don't think so. Don't need, but maybe they can ask, okay. So just make sure you know Coulomb's law, you know electric field. So definition of electric field is here now. Electric force experienced per positive charge placed at the point. So this is our definition. You can highlight, you can write somewhere. So we should know electric field definition. Let's continue. Draw electric field lines. Okay, we are going to draw electric field lines between these two. What we know, please remember, electric field lines from positive to negative. As you see, you have positive 20 microcoulombs, and then you have negative 14. So electric field from positive to negative. Let's see, yeah, this direction, as you see, direction 1 mark, shape 1 mark, and then field lines not touching each other. And then so it's coming from memorandum. So please be careful when they ask this. Most probably this question is coming. This kind of questions, they like this kind of questions. Electric field lines, so they shouldn't touch each other. Please be careful about that. Direction always from positive to negative. If you have positive, they repel, negative, also repel. But if you have positive, negative, from positive to negative. So you have 3 marks question here. This kind of questions, 2.2 done. Next question, 2.3, asking you calculate the net electric field at point P. All right. How we are going to calculate electric field? This kind of questions we have done already. First of all, on P, you must just draw force diagram. Let's draw first. So we have point P, negative 14 attract. So this is your direction of E1. And then positive, it is positive 20. So also to the left, it is because repel. So E1 and E2, same direction. If you have same direction, what's going to happen? You are going to add them. All right, so yeah, we are going to just calculate E1 and E2 and we'll add them because they have same direction. Okay, let's continue. Yes, we are using these calculations. You can see this is our E1. But just let's write E1, R1, R1, E2, Q2, R2. So you are calculating all. E1, as you see, K is 9 times 10 to the power of 9. And then Q1 is 14 times 10 to the power of negative 6. Why negative 6? Because micro. And then already in meters, so you don't have to convert distance using 1. Why it is 1? Because total distance between charges is 3 meters. Distance between point charge Q and point P is 2. How many meters left? 1 meter left between Q1 and point P. So you are using 1. And then calculating direction to the left. E2 also same steps. You are using K times Q2 over R2 square, and then you are getting 4,5 times 10 to the power of 4 n times Coulomb negative 1 to the left, same direction. You are adding them. We can draw a free body diagram also here. Free body diagram, we have E1 and then we have E2. E1 and E2 same direction. Because of that, we are adding them to get final answer. So net electric field is 1,71 times 10 to the power of 5 newtons times Coulomb negative 1. This is unit of electric field. Done. So this is our question 2.3. Let's see question 3, last question for today. Question 3 is coming now. Similar question. Let's see what they ask. We have two charge identical spheres, okay, 6 microcoulombs and then 6 microcoulombs, and then point O. Now we have point O. Distance between charge A and point O is 10 centimeters. Distance between point O and B, charge B, is 90 centimeters. What we are going to do, we are going to change units from microcoulomb to coulomb, and distance from centimeter to meter we must convert it. And then we can carry on to calculate. Let's see what they ask. Number 1, calculate the magnitude of electrostatic force. Okay, it's an easy one. If the charge on each sphere, all right. So force between two charges is 1, F equals K times, but I'm not saying easy anymore because my learners, if I say easy, they're gonna fail. So F equals K times Q1 times Q2 over R square. So K is 9 times 10 to the power of 9. Q1 is 6 times 10 to the power of negative 6. Q2 is 6 times 10 to the power of negative 6 over 1 square. So you are getting force between charges. I hope it's fine. Just easy. So, okay. I'm not saying easy. Let's carry on. So F equals just, all right, let's continue. 3.1, calculating magnitude of electrostatic force. I hope everything is fine. You are using our formula. So let's continue with next question. So asking you, is the force calculated question 3.1 force attraction or repulsion? So what can we say? If we have same charges, they repel each other. If we have different charges, they attract. So our answer is repulsion because we have positive and positive charges. In another one, 3.2 done. And then next question. For now, you are changing distance, making half, okay, distance half, and charge on A and B double. So what is your new charge? How many times bigger or how many times smaller? So asking this question 3.3. Answer is 16. As you see, just writing 16. They don't ask you calculate. They don't ask you new force, how many newtons. They are just asking you how many times bigger, 1 over 16 or 1 over 6, 1 over 5 or 5 times bigger. So how we are getting this number? So let's try to explain, but you don't have to show during exam. Just to understand, we are writing down distance, getting half. So for now you have 100, but let's carry on with R and R over 2. If you have R, your formula is F equals K times Q1 times Q2 over R square, right? So 1 over R square. So if you make half, you have 1 over 2. If you make 1 over 2, because I'm writing like this, 1 over 2, it means you are getting 4. Because just swap, or easy way, if you see 1 over 2 half, just swap like this and square, and then you are getting 4. All right, 1 over R square. So I'm using that 1 over 2 half, making half distance. So 4 times bigger. But they said 16. But also charge getting double. So 2 Q1, 2 Q2, 2 times 2, 4. As you see, 4 times bigger because of charges, another 4 times bigger because of half distance, making 4 times 4 is 16 times bigger. Another option to calculate, but they said don't calculate it, but to understand, you can use this option also. This is our F2. All right, so for F1, what we know, for F or F1 is fine, K times Q1 times Q2 over R square. So you can write K times 2Q1. We are not busy with numbers, all right? Q1 is 6, 6, we don't need. So we're just making double. So Q2, we have another option with numbers. I will show you that one also. Just make sure you are getting this kind of questions. And then R over Q, so, all right. And we know, just let's say, X times F. X times F. We don't know how many F, just say X times F. So this is our F2. Maybe we can start from initially, we can say F2 equals X times F, because we are looking for how many times bigger new force between this. X times F we said. F2 is this one. F, we can write F from now. We can just write. What is F formula? F2 equals XF we are saying, and then X times, X just looking for this number. Okay, X is this number. We will get it now. So K times Q1 times Q2 over R square. So from now, what can we do? K cancel each other. And then Q1, Q2, Q1, Q2 cancel. And if you write this one, what is left on top? 4. 4 over R square over 4 equals X over R square. So R square also cancel each other. What is left this side? As you see, too many calculations, but maybe some learners, they like this calculation, it's much better for them. So 4 over 1 over 4, let's say 4 over 1, so you are getting 16 this side. In maths, you know already, 4 over 1 times 4 over 1, 16. So 16 equals, what is left? It's X left, that's it. This option you can use to calculate 16 times bigger. Another option, they said don't calculate, but it's fine. You can use extra paper and you can calculate on question paper. You can just make sure to get correct answer, because they are going to change these numbers. But easy way, I like this one. 1 over 2, just change it and square, and then like this, 1 over 2, 2 over 1, square is 4. Sometimes they are going to ask you only half sphere. You know, distance make half. But now distance and charge. But if they ask you only charge change, multiply and get it. But now changing distance and charge. So this option, I hope you like it. Another option we have for this kind of questions, you can calculate for first position. It is a long way, but it's another option you can try. We calculate already, right? What was our force? Let's see. We calculate already for 100 centimeters. For 100 centimeters force. Let's see now. It is 3,24 times 10 to the power of negative 1. Okay, this is our force. And we are going to change what they said. And we are going to calculate one more time. And then you will see 16 times bigger. It's a long way, but let's try. I'm not completing, just showing that method also. They said distance half. Now you have distance 50 centimeters is equal to 0.5 meters. And then charges double, 12 microcoulombs, and then this is 12 microcoulombs. Use these numbers and then calculate F2, and then you will get 16 times more than what you got for question 3.5. All right, you can use this option also for this kind of questions, which one you like. I like first one because easy one, but other options also for you. You can try which one is easy for you. So question 3.3 done. Now they're asking you calculate the net electric field at point O. Okay, we are going to calculate E1, E2 one more time and calculating E net. So E1, which direction? Force diagram we are doing just now. E1 to the right because positive always repel. Positive always repel. This is also positive, so E2 this way. E2 this way. Now we are going to get E net, E1 minus E2 or E2 minus E1. Depends because which one is bigger. We must calculate first. Okay, let's calculate our E1. Let's say E1, E2. E1 is K times Q1 R1 square, and then you are calculating 0.1 square, and then you are getting to the right. Similar question as you see before, we have done already this kind of questions. Q1, Q2, R2. You are calculating 0.9 because 0.9 left. 0.9, 90 meters. 0.90 centimeters, sorry. 90 centimeters, 0.9 meters left. So you are calculating E1, E2. Let's draw our free body diagram also. E1 this way and E2 to the left. So which one is bigger when you calculate? E2 is, no, which one is bigger? E1, yeah, because 10 to the power of 6, 10 to the power of 4. E1 is more than E2. E1 minus E2, and direction, same direction of stronger electric field. We are calculating, first of all, you should get direction, of course. It's getting easy for you. I don't want to just more because we have done, you understand. We have done for today. Thank you very much. See you next lesson with our lesson 6.